Here we look at a simulation created of Bay Campus, Swansea University using open source tools like OpenStreetMap, JOSM, NetEdit, Sumo. OpenStreetMap is a mapping tool that provides us with editable map data. This is what Bay Campus map looks like on OpenStreetMap. JOSM is a map editing tool. This is what the Bay Campus map looks like on JOSM. NetEdit is used to add traffic lights, create routes for vehicles and bus stop. Sumo is used to model and analyze traffic scenarios. I have used Sumo GUI to show the movement of vehicles on campus map. This is what Bay Campus map looks like on NetEdit. We can add traffic lights. Create routes making sure the attributes are set correctly. We run this on Sumo. This is what the traffic lights look like and the Bay Campus map on Sumo. We can change the speed of the simulation using this. We can use NetEdit to create bus stops that can be seen here. Delaying is necessary to be able to see the vehicles moving. When we run this we see red, yellow, and blue shapes moving on the map. Now if we change to real-world setting we see that the shapes have changed to a bus and two cars. The cars take the route they were assigned and the bus loops around the campus. We can delay the simulation to slow down the movement of the vehicles. We can play around with the settings if we want. We can edit the route file to increase the number of vehicles, and we can also change the speed at which these cars move and when they start. In this case, I have programmed it to start from 60 seconds. In this video we will see how we can program the vehicles to start at different times. When we run this we see first bus starts at 0 seconds, the car starts at 10 seconds and the second bus starts at 40 seconds and take their respective routes. Another thing we can notice is that we can program these vehicles to move at different speed as well. It's easier to understand the movement of vehicles when we have a satellite map. Here we have a rough picture of the simulation on the map. On running this we can see the movement of vehicles on their respective path, that is the buses loop around the campus and the cars go along the Fabian Way. Now we look at the campus simulation using tools like Omnet++, Vanes, Sumo GUI, Inet and Qtenv. Here I have explained each tool in detail. We imported our simulation into Omnet, then used Vanes to implement V2V vehicle-to-vehicle communication. We also used Inet framework for implementation of various protocols. At last we used Qtenv to watch simulations run in real time. We imported Vanes and Inet framework into Omnet and made sure our simulation uses them correctly. We have hoster that is a static host, radio medium, and host B also a static host. We have a configurator that assigns IP address to our hosts. We see hoster sending wireless signals to host B. If we look at the packet logs we can see that UDP packets are transferred between hosts. We can also see the destination IP, in our case IP address of host B. This is how we can get two static hosts to communicate with each other wirelessly. Here we have used a visualizer. These rings represent signal propagating through the medium. Earlier our host was static, but now we have changed it to move. Earlier we used static host, but here we see our simulation of Bay Campus. When we run it we see our Bay Campus map and nodes, that is our vehicles moving the map. As soon as there is an accident, node 0 tells node 1 about it, which shows that our wireless vehicles are communicating properly. If we see the packet logs, we can clearly see the nodes talking to each other and the packets being transferred along with the protocol used, length of the message. We see node 1, that was our car, goes on the Fabian way as it was supposed to. The buses also move on the assigned paths, and then the simulation ends after 200 seconds as programmed. Here we have an attacker, that is a static host. We see host A is sending packets to both host B and the attacker. If we look at the packet logs, we see that the attacker is sending packets to both hosts A and B. This shows that the attacker is communicating with both sides successfully. Here we have an attacker on our Bay campus simulation. We see attacker is successfully communicating with node 0. In the packet logs, we see the attacker is sending probe request to all the vehicles moving on the map. Probe request are active attempts to gather info. Here we are trying to flood the node with loads of DDoS message fragments. We see that the attacker successfully talks to node 0. If we look at the logs, we see the attacker sends DDoS message fragments that are received by node 0. If we look at the logs, we see the attacker is using the same MAC address as the nodes to send messages to them. When the nodes receive these messages, they think it's from the other node and not the attacker, as it comes from a familiar MAC address. We see that the attacker spoofs the MAC address of node 1. This shows MAC spoofing. We see here that the attacker sends packets to both node 0 and node 1 and tries to flood the nodes with messages. We see that node 0 stops sending messages to node 1 or the attacker as it gets overwhelmed by the packets sent by the attacker. This shows DDoS attack on the simulation.